Hi guys, my name is Salm Hamis Kikusa. I'm going to present on the concept of the gradient of a straight line. The other name of gradient is slope. So in the course of our presentation today, I'll be using these words slope and gradient interchangeably. Please don't get confused. Let us get into the business. What is gradient? The word gradient simply means how steep the line is. Have a look at the screen. We have these three lines. We have this black line, red line, and this yellow line. So by using this definition, we can obviously see this red line has the greatest gradient because it is the steepest. This is followed by the red line, and this yellow line has the least gradient. Okay, so this black line is the steepest, so it has the greatest gradient. As you can see, the red one follows, and the yellow line has the least gradient. Now let's see the types of gradients. There are 4 types of gradients. A line can have a positive gradient, or it can have a negative gradient, zero gradient, or undefined gradient. What do they mean? Let's have a look. Let's first have a look at the negative and positive gradients. Here on your screen, you will see these 2 lines. We have this yellow line, and red line. Let me start with the red line. When we read, we always start from left to right. So we'll use the same principle to explain negative and positive gradient. So in this red line, as you can see, point C is on the left of point D. So when we read this gradient, we will start from C to the direction of point D. Now as I move from C to D, I make a downward movement. The downward movement is negative gradient. So this red line has a negative gradient. So the gradient here is negative. So this one has a negative gradient. Now let's have a look at the yellow line. Here I've shown the 2 points on that line, point A and point B. Point A is on the left of point B. Okay, so we follow the same principle that we are starting moving from the point on the left. So when I move from A to B, I make an upward movement. An upward movement is positive gradient. So this line, the yellow line, has a positive gradient. Okay. Let's have a look at zero gradient and undefined gradient. When you look at this red line here, you will see all the points are at the same level vertically. There is neither rising nor falling. There is neither upward movement nor downward movement. So we say this one, because there's no rising, there's no falling, we say this is zero gradient. So this line has a zero gradient. Now let's have a look at the blue line. When we look at it, we will see all the points on this line are on the same position horizontally. This is to say, all the points have the same x coordinate. Okay, so the gradient of this line is undefined. So the gradient of this line is undefined. So if you want to remember, for zero gradient, remember about the plateau. Plateau is flat, so is a zero gradient. Undefined gradient, remember, a cliff. Okay, so that is a free falling, it's straight downwards. Okay, so is undefined gradient. Now, we have seen what is a slope or gradient. We have seen the types of slopes or gradients. Now, it's high time to answer the question, how big, how big or how small is the gradient of a given line? So now, we have to get into the formula. To answer the question, how big the gradient is, let me introduce to the basic formula which we use when calculating gradient. The formula is gradient is equal to rise over run. Okay, this is the basic formula. There are different extensions to this formula, and one thing that you have to remember at this point, we use letter M. In mathematics, we use letter M to represent gradient. Okay, so I can write gradient is equal to rise over run. M is equal to rise over run. So the other extension, you might find that they have written gradient is equal to y increase over x increase, or they can write change in y over change in x, or they can write difference in y values over difference in x values. X values. Okay, so we have gradient rise over run. This is the basic formula, don't forget it. Okay, these others are extension, so this is the basic formula. The other three are extension, but these ones becomes more important when we find the gradient given 2 points. When you're given 2 points, 2 coordinates in the line, and then you are asked to find the gradient, this one, we will be using this one. We will see later on. Now let's get into business. Okay, let's find the gradient of this line. So we know the basic formula is gradient. Allow me to use M for gradient is equal to rise over run. Okay, so let's pick this point. Let's pick this point O, okay, to P. Remember, we are starting from left, point on the left. So rise means we are going vertically. Okay, sometimes rise might mean falling. So if it happens we fall, this is negative rising. So to go to point B, I have to fall. Now, how many steps? If you count these boxes, you'll see 1, 2, 3, 4, 5. And because it's falling, this is negative rising. So downward movement is negative. So it's negative 5. And run, so I've fallen up to this point. Okay, running is sideways movement, horizontal movement. Now from this point, I move to the right. Moving to the right is the positive movement. Okay, so we are moving in a positive sense. So 1, 2, 3, 4. So I have 4 boxes. Since I've moved to the right, is a positive movement. Remember the principle on working on integers. When we divide this negative 5 over positive 4, this will give me negative 1 over 4. So the gradient of that line is negative 1 over negative 1 over 4. Negative 1 over 4. Okay, let's see another example. We have another example here. This time around, we are finding the gradient of this yellow line. Remember, we are starting from the point on the left. Okay, the point on the left. Our formula M for gradient is rise over run. Rise over run. Okay, so the point on the left is A. To go to the level of point B, I have to go upward. Upward movement is positive. Excuse me. So here 1, 2, 3. Okay, so I have moved 3 boxes upward. Upward movement is positive, so positive 3. And run, horizontal movement. From there, I move to the point B. Okay, so I have to move to the right. The rightward movement is positive movement. How many boxes? 1, 2, 3. So over positive 3, this gives me 1. So the gradient of that line is positive 1. Okay. Now let's see how we can calculate the gradient when we are given 2 points. Okay, suppose now we have been given a line like this and we want to use the points. Remember I told you you can use the same formula. Gradient is equal to rise over run. Okay, so we can just, from this point A, where do we go? This is the point on left. We have to go upward movement. So how many boxes? So here I have numbers. Okay, so each 2 boxes is 1 unit. Okay, so here 1, 2, 3. Okay, remember, see here each box is 2 boxes, 1 unit. 1, 2, 3. Okay, so I've gone. I can even count 1 box, and here I will have 6 boxes. It will mean the same. Okay, so I can count even the boxes 1, 2, 3, 4, 5, 6. Okay, so I've gone upward 6 steps. So the upward movement is positive. Then from there I count how many boxes? 1, 2, 3, 4. Okay, So I have gone 4 steps on the right. Right is positive. So this is 1, 2 over 4. Okay, so this is equal to 1.5. So the gradient is 1.5. So let me write this here. And let's compare when we use the other formula. Sometimes it becomes difficult to use directly this formula of rise over run because you might be given the points. Like here we have point A. If we read it from here, you will see this point is 0, -1, and this point B is 2, 2. So now allow me to use the extension of this formula, rise over run. So this difference in x, difference in x, difference in y, difference in y values over difference in x values. Okay, so difference in y values over difference in x values. What does it mean? So here we have our points. Point A, 0, -1, and point B is 2, 2. So as you can see here, we can call the first point, this point we can call x sub 1, and the corresponding y value we call y sub 1. Here we can call x sub 2 and the corresponding value of y sub 2. Now, difference in x values, difference in y values, So y here is 2. So we can take 2 minus 1. 2 minus -1. Difference in x values, x value is 2 minus 0. So I repeat, you should try to revise on integers before starting this topic. So this will make 3 over 2. Okay, so 3 over 2, this gives us 1.5. The same gradient as we got here. Okay, the same gradient as we got here, 1.5. So sometimes you might find they have written this formula in notation. Remember, we took this minus this, so difference in y, so we take this y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, when you start with this in y, in x you should start with this. Don't do y sub 2 minus y sub 1 minus x sub 1. No, it's not allowed. Once you start with this in y, and the denominator should start with this, y sub 2 minus y sub 1. Let's see how we can solve these questions very quickly. Find the gradient. So let's part A, solution. So we have the point 6, 4. Let's call this x1, y1. And we have 8, 10. Let's call this x sub 2, y sub 2. So the formula tells us difference in y. Excuse me. So difference in y values. Difference in y value. Our y value here is 10. So we take 10. Here our y value is 4, minus 4 over difference in x values. Remember, I started with this. I have to start with this here. So difference in x value 8 minus 6. So here gives me 10 minus 4 is 6. 8 minus 6 is 2. So the gradient is 3. So here our gradient is 3. Okay. So even if I start with this one, it will give me the same. Let's see. Remember our answer. Our answer is M. Let me write here is 3. Our answer M is 3. So let's start the other way around. So let's take, now let's take M is equal to, okay, now I did this first, difference in y value over difference in x value, starting with y sub 2. Now I want to start with y sub 1 minus y sub 2 over, here should start with x sub 1 minus x sub 2. So this gives me, so here y sub 1, so I have to start with 4 minus 10 over 6 minus 8. This gives me negative 6 over negative 2. Negative number, when you divide two negative numbers, the answer is a positive number. So this will give me positive 3. So the same value as that one. So let's do part B. Okay, now let's do part B. I just want to do it the simple way. Remember, when we're dealing with points, our formula is gradient is equal to difference in y. Difference means minus, where y's coordinates are here. So difference in y, I take negative 5 minus negative 4 over difference in x. So our x coordinates are here. So remember, I started with this y, so I have to start with this x. So it will be 7 minus negative 3 is equal to, the knowledge on integer is very important. So this is negative 5 plus 4 over 7 plus 3. So here we get negative 1 over 10. So our gradient is negative 1 over 10. Okay, so let me do the same question. Let me complicate it a bit. Okay, let's see if we to get the same answer. So here, this is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2. So gradient is equal to difference in y values. So y sub 1 minus y sub 2. I could as well take y sub 2 minus y sub 1. So since I've started with this, I have in x I have to start with x sub 1. So x sub 1 minus x sub 2. And then I just take here negative 5 minus my y value here is negative 4 over, I will take my x value here, x is 7 minus my x value here, negative 3. So this one gives me negative 1 over 10. So our gradient here is negative 1 over 10. Negative 1 over